Hi, my name is Felipe Mendes and welcome to my Monster Scale Summit talk on workload prioritization. I work at ScyllaDB as a technical director. I am a ScyllaDB committer, one of the co-authors of Database Performance at Scale, and I love puppies, which therefore makes it mandatory for you to like me, as a person. So, what is workload prioritization? Rather than trying to explain it with words, let's actually see how it works in practice. So, consider you have a real-time workload running like the one here shown on the screen. On the right terminal, you can see respectively our average and P99 latencies. So this workload simulates seasonal traffic and fluctuates over time, thereby showing that pretty much the curves that we are seeing here, both on CPU and on requests over time. And this is a common pattern which often represents user behavior or processing of stream events. Sometimes you reach a peak traffic and other times your system receives less traffic. And that's exactly what we observe here in the ScyllaDB monitoring. And as we can see, latencies are also very low and under control. So let's do this now. Let's start an ETL job and observe what happens. I'm going to switch my terminal tab and I'm going to kick off this job. So now if we go back to our main application terminal, we can see that our latencies actually started to accumulate. And this is a sign that the database is no longer able to process its incoming requests in a timely manner. It is no longer able to meet its implied schedule, and therefore latencies start to accumulate either in user space or in a queue. So naturally, when you start seeing your requests accumulating like this, your natural reaction is going to be, well, let's kill the ETL job. And that's exactly what we did. So as we go back to our main application job, you are going to see that it's now trying to actually recover from the backlog of requests it accumulated over time. So killing the job sort of helps, but it takes some time for our application to recover. So here is basically the very same view, but ran over a prolonged period of time. Over time, we can see that everything is running happily. Our latencies are very low in microseconds. And then something happens. Basically, we kickstart our ETL job. And then what we see is that we no longer observe those sinusoidal curves as we were seeing before. And as a result, our latencies basically start to grow. And likewise, this happens because our ETL job is actually consuming most of the capacity and the database is not able to meet your real-time requests following its intended implied schedule. So to summarize, what we are seeing here is basically an unfair system. And after our ETL job finishes, we can see that our application starts trying to recover and trying to process its backlog of accumulated requests. So this is clearly not nice. So how we can fix that? In order to fix that, we are going to basically make use of workload prioritization. So in the SQL S8 tab, we are going to create a new user. And I'm going to call this user prioritization, and I'm going to give it a password of the same name, prioritization. And I'm going to allow it to log in, and I'm also going to assign it as a super user. Next, we are going to define a service level, which I'm going to call simply WLP for workload prioritization with 200 shares. And then next, we are going to basically attach this service level WLP we just created to the prioritization user or role we just created. Okay, and just like that, what we are going to do next is basically we can see that our application has already recovered from processing its backlog, and we are going now to process again our requests in the ETL job, but now using the new user we just created. If I wrote that correctly, of course. Prioritization, yeah. And then it starts basically doing the same thing as it was doing before. And if we go back to our application, here is the difference. If you look at the latencies, they are now under control. Okay? So now if we simply go and take a look into the very same run, but over a prolonged period of time, here are a few things that we can see. First, notice that the database is now able to meet with the real-time implied schedule, and the sinusoidal curves are actually maintained. But there is another cool thing that's actually happening here, which is this new sinusoidal curve that appeared. What this means basically is that you will observe that although we also have a sinusoidal curve, it's actually in the opposite direction than our real-time one. What this means is that as our real-time workload is basically outside of its peak, ScyllaDB basically gives more CPU capacity to our ETL job. And then as our workload requires more capacity, ScyllaDB gives less CPU time to our workload prioritization work. All right. So that's basically what workload prioritization is. Let's move back to our presentation. So there are many ways you can use workload prioritization. One way is to differentiate real-time versus batch processing, like what we've shown here. You may also define different priorities for your reads or writes. For example, you might want to give less priority to heavy ingestion jobs while preserving your users' read latencies. And of course, the ability to configure different priorities on a per application or per workload basis to drive consolidation, in turn reducing infrastructure costs. For example, you can consolidate several small tables with varying and even skewed access frequencies under a single ScyllaDB cluster and assign different priorities for each. And one thing you should know is that workload prioritization is, of course, also compatible with the ScyllaDB DynamoDB API. Here are a few examples of users relying on workload prioritization on production. ShareChat makes workload prioritization as their ally for driving cost savings. They previously spoke about how workload prioritization helped them at P99Conf, and they are also speakers in this year's Monster Scale Summit. A famous social network platform uses workload prioritization to run their daily batch jobs for reporting. As social networks are really never dormant, workload prioritization helps on ensuring that their users' experience is never disrupted. And a media streaming company uses workload prioritization to assign different priorities for applications reads and writes as required by their respective SLAs. So, this is what I had to present. I hope you liked it, and feel free to follow me on social media. Thanks.